Okay, welcome, Favor. So it seems that it's you and I that are going to be discussing today. Hmm. Okay, Favor, are you ready? I'm ready. Can Favor hear me?
Yes, sir. I am.
Okay, wonderful.
Hello, sir.
Yes, I can hear you fine. Can you
Hello,
also?
sir.
Yes, can you hear me?
Okay, sir.
Okay, wonderful.
Yes, sir. I can get you clearly.
Okay, then that's fine. So, on
Yes,
my
sir. I can get you clearly.
wonderful. So on my screen, today we're supposed to talk about the kernel. So it was an open topic, and I figured out that before we talk to the kernel, why don't we talk about the first process that it is involved in, which is the boot process in the Linux architecture. So over to you. Tell me, what do you know either about the boot process or the kernel? Then from there, we'll start. Over to you, Favor. Is Favor, the floor is yours. If you're talking, I think you're muted.
So my connection was not that good.
Oh, okay, that's okay. You can continue.
Did you ask a question?
Yeah, I was saying that you could tell me what you know about the boot process or the kernel, and then we can also just continue.
Can you get me, sir?
Yes, I can hear you.
Hello, sir.
Yes, I can hear you.
I was saying the kernel is the core. Okay. The kernel is the core of the operating system. It manages a computer's hardware and software. The kernel acts as a bridge between hardware and software components of the computer.
A boot between the hardware and the software.
It acts, yes, sir, hardware and software. It acts as a bridge between them.
That's true. So thank you. Yep. So I'm going to first of all look into the meaning of these words. I know the acronyms, but I don't know the words. UEFI, ESP, EFI, and which one? The NV1. Yeah, and which one do I not know again that I can see? So, real quick, I can share this, right? Wonderful. hmm So literally, I like this particular stuff because it helps to explain a lot, right? Mm. When you power on your computer, right? Actually, what is acting as a bridge between your hardware and your software, right? It's there are two bridges here actually, right? This is the first bridge. Uh, I mean this gray colored stuff. I don't have stuff to do. And then this is the second one. So there is some kind of intermediary between the two of them, right? And generally, the one that I consider to automatically go as unlisted on instruments. Okay, wonderful. Um, Generally, what I consider as the stuff, the breach is, I don't know which one. It depends on people. So when you power on your PC, what you're doing is that you are activating your hardware system, not so. And when you activate your hardware system, it's of course a programmed component. You have the motherboard there, the CPU, the keyboards, and the stuff that are needed for it to work together, right? And in those days, the hardware was literally doing a lot of stuff, right? Early computers was just about zeros and one, not so, because it was a hardware operated system. Literally, all these other things were not there. And then the concept of software came in, right? And then that's when you it evolved to what we have now. So you have the hardware there. When you do the hardware, you power on the hardware. There is something called the firmware, right? People call it BIOS. It was first of all called BIOS, Basic Input Output System. And then what most of us use now is the UFE. That's what I usually call it, UFE. And the UFE, it's the Extensible Firmware Interface, right? It's an interface now. So when you do that, this small program, it's a small program that's inside of your computer somewhere. I'm not a hardware person, but this program triggers what is called the power on self test, right? Which it's a hardware functionality, not so. It simply says that, hey, go to all my hardware components, my keyboard, is it working? If it's working, tell me yes. The motherboard, is it working? Yes. Is there a RAM there? That kind of thing. Yes. And those other stuff, right? When so this is what this step is about, this post step is about. And it's pretty much important because especially if you'll be operating stuff on bare metal, right? It's important for you to know these things then, because you know like how to troubleshoot. Usually, when you do stuff and it's working, especially now in the age of AI, you can use AI to do anything. But the most difficult thing is understanding the fundamentals in order to know where to start your troubleshooting, right? That's where people get stuck. And that's why this I like to emphasize on this kind of information, right? So this stuff happens. So at this stuff, when to know that this stuff happens, it means that we just need to know what's happening here to see stuff. So if this thing is not completed, most of the time, if this post is not completed, then you usually get something like a beep on your computer, ping, something like that, and then you show one of my favorite errors is is saying that there is no operating system, la la la, la, because it's going to check whether there's an operating system there or not, right? And on this step, so the firmware reads like your bootloader. Where is that bootloader stored, right? In those early days, it was stored in the small thing called the Sysmos battery. And in today's computer, in today's architecture, present day architecture, it's stored in what's called the V and the NVRAM, right? And so if your firmware goes there to try and read the boot order and or boot entries and it does not find anyone, right, it's going to return like a problem, right? So first point to note, I prefer to say this thing practically, right? Not this is not some kind of theory teaching class. Is that you need to understand that these steps are there and it's something that the computer respects in order for you to know what is wrong with your computer, right? If you try to put on your computer, the way it behaves should tell you which of these steps, what is going on. And because right now, if this step is passed, that is, it succeeds to read your boot entry, then it's going to find one of two things. It's either going to find a BIOS mode or it's going to find a UEFI mode, right? And most computers right now have both, right? So UEFI mode is what you call 32/64 bit operating system, right? Favor, do you follow with me?
Yes, I'm following.
Favor is still there with me. And Marivon, Marivon, welcome. So, if they say your computer can support both a 64-bit software and a 32-bit software, they are actually saying that your hardware architecture is based on the UEFI mode. That's what it means, literally. So at this point, really, we are still talking about the hardware. To be very honest with you, we have not gotten to the software part, right? So on inside this middle layer stuff like this is still these are still hardware operations, right, in your computer. Access secret key. You can listen to, okay, that's fine. Sorry about that. So you right onto this point, you are still on the hardware level, right? So you have not still gotten to the stage where you need to load the operating system into the hardware. To be honest, frank and honest, right? So I'll talk mostly about the UFE because the UFE literally right now supports the BIOS mode. So you can literally choose. But usually it's important to know the two of them because, well, you could be working with someone whom is from the 90s and then they are usually not too flexible in changing this stuff, right? So in the UFE mode, once the firmware figures out that you're running the UFE mode, then it's going to trigger a program there that says that you should run an executable, right? There is some kind of executable that is being stored. They call it I've forgotten the meaning of this E I don't know what it means, but this EFI system partition, right? uh, Literally forgotten their full meaning, but it's just a special kind of storage, right? So there's a special kind of storage on your hardware system that is used to both is used by this stuff. Mhm. Yeah, no, it's okay. Oh, sorry. Yeah, sorry about that. This there's some kind of storage. Again, I'm not the hardware expert, right? But I just know that there's this storage stuff. So Yannick would explain to you guys. I'm sure he has better ideas. I'm sorry about my camera. Uh, there's this storage there that's in charge of um, is used for the boot purposes, right? I know that on the Linux system is like slash boot slash EFI, right? And that's what I know. And that's what's important for me. And the hardware part of it's not really my concern, right? So there's just something in that file that this UFI program will go in there and run it. So it's a script that is going to be run, right? And then that script is literally going to awaken another kind of script, right? Most people call it a grub. Some people call it the direct kernel EFI. Again, I've forgotten the meaning of EFI. I'm sure it's extensible firmware interface, something like that. I think I've forgotten. But then that's what it is. And so up onto all these arrows, you have a hardware program that is just running some scripts, right, from a spatial storage. Literally, that's what is happening. So it runs these scripts. It is these scripts now that will awaken now a software part. I mean, we're getting close to the software part that we call it the bootloader, right? The bootloader simply says that, hey, uh, you the this script, there is a software part of this system somewhere, right? It's called a kernel, right? And it's usually the kernel, and there's also something called the init RAM FS, right? Init means initialize, RAM means random access memory, FS means file system, right? So again, Linux is based on the file system. Everything on Linux is a file, right? And if you want to awaken the Linux system, then what you want to do is you want to activate the file system. Literally, that's what it means. To activate the file system, that's what they call the kernel parameters, right? So you take some kernel parameters that have been loaded by the bootloader, and then all of these things starts, right? Once this is done, then the kernel start running processes. And to run a process again is about files, about which file is running, right? So some of those process is that it mounts the file system on the hard drive, right? So it mounts it, and then it start loading other services, blah 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 blah. One of those services is what you call the user login. There's a name for it, but well, the user login, right? When you now see your user login and then you're prompted to enter your password in order to get access to your file system. Literally. So, did I make sense for this introduction?
Yes, sir. All good. All good.
Sure. Are you sure?
Yes, sir. So far, so good.
Okay, wonderful. Because what I am trying to do here is that when you have a problem, also, then you should be able to troubleshoot that stuff. Literally, you should be able to troubleshoot it. So, well, we're not going to do all of this today. Trust me, I did this some time ago and it was kind of long. So I'll walk you guys through the boot process already, and literally, this is the flow of it. And what you need to know is that for you to talk about the kernel, it's difficult to talk about the kernel without talking about the hardware, right? Because what is the purpose of the kernel? The purpose of the kernel is that the kernel is an instrument through which you can use a software, the user can use a software to instruct. Okay, I can see myself, I'm back. You can use a software to instruct the computer system, right? So you can create or give a computer operation and get back an output through a software. That's literally the purpose of the kernel. So the kernel is the one behind the scenes that is facilitating this process. If you delete your kernel, you'll not be able to use any software on your system. And it's very easy for you to do. Go to your Linux system, go to /boot/ EFI, delete that part of your stuff and see whether you'll be able to do anything. For example, right? Who wants to try? Okay, no volunteers. Okay, then that's fine. So the point that I want to make is that when they say the computer is when they say you're using a computer system to perform a particular task, in reality, it is your hardware device, not so, that is carrying out that operation. And I mean, I'm sure once that the Liani can correct me about this, there's Yannick, there's also Loni, right? I'm a software person, so I don't know too much about hardware. But I know that if you're using a computer to perform any task, the task, right, that task is being performed not by your software, but by your hardware device. So there is something that carries the instruction from your software because software are there so that you can give instruction to a computer system in human language. Okay, that's the purpose. You can give a computer instruction in human language. Remember, the only language that the computer understands is 0 and 1. So if you don't want to use a software to give a computer system an instruction, then you need to write that instruction in the form of 0 and 1. And you don't need a software, you don't need a kernel. And by the way, people are doing that if you don't know. Yep, people are doing that. People are still doing that in 2025. There are people whom you go to their stuff, you see only a terminal, and on that terminal, they are only writing 0 and 1, 0 and 1, but they know what they are doing, right? Literally, that's what happens. So the kernel itself, it's you cannot talk about the kernel without talking about the hardware because that's the relationship that I just pointed out, right? So honestly, that's the very high overview of everything. So to even get to the kernel first, the first two things to understand, which is your personal research to do, or it's I'm sure Yannick has already taught you this, the functions of the BIOS or the UFI, the bootloader, and then before you get to the kernel, what does kernel do? So at every stage here, you just have some instructions that are being done. For example, here you have the post, which means the power on self test, means that the computer system receives a 0 signal or a 1 signal, I don't know which one exactly. And then that 1 signal or 0 signal means that the computer should come on, right? The moment that signal is received, for most of us, you will see a light will pop up on your hardware. That's part of the power on self test happening, right? You see stuff, the computer system will be like, okay, we are syncing for a while, and then your screen, something will come up, pop up. That's all part of the, that's because this process here is being executed successfully. The moment you see the logo of your computer, right? Lenovo, la 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 la, that kind of stuff is because this stuff is being this part is being executed successfully. At the moment you see Ubuntu, um, hmm, the what? Okay, sorry. Let me set it. So yeah, so the moment you see the Ubuntu logo, la la la, that kind of stuff, for example, it's because you're getting this kernel stuff, right? And then they are literally scripts that are being run. So there's usually no graphic stuff that happening. And I'm trying to just give a high overview to tell you that these are the processes, and we're not talking about the kernel just yet, right? And wonderful. So the BIOS runs on 16 bits legacy mode or 32 bits. Okay. Okay. So if it's interesting for you guys, then we can talk about this init stuff. La 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 la. But the whole purpose for today was to talk about to give this overview of the kernel, right? How the hardware part is related to the kernel. And then what I want to do next is not theory, so I don't intend to go through all of this stuff. What I want to do next is to talk about the kernel, the internals of the kernel, but I don't want to talk about it through theory because you already have people for that. So what I want to do is the workshop proper, right? And then so that we can we can get into the details of that. So who is still with me up to this point?
I'm still here, sir.
Okay, wonderful.
Sam, see it too. I'm
Okay,
still.
you do you guys have the whole day? Okay, wonderful. So I will also go ahead to just talk about maybe everything. Sorry, just because we're refreshing before we write any comment, and I'll talk about the responsibilities that you can see on the kernel. And literally, when we say that if you delete the kernel, it means that you have deleted the software part of your PC. So you can only give instructions to your PC through ones and zeros, right? If you know how to do it. That's because everything that concerns how humans can instruct a computer system, or I'm going to say a hardware system to be very specific, because a computer system will include even the software part. But what I want to say is everything that is involved in using the hardware system, in instructing the hardware system to perform a particular task and give you back the output, has to do with the responsibility of the kernel, right? You guys can tell me about what the CPU is, and then I can elaborate. Who wants to go? Marivon, do you want to go? Okay, I'll go. So that's fine. So when the hardware system receives the instruction, right? How does the hardware system know which instruction to prioritize, which one should be done first, which one should be done last? and right, that kind of stuff, right? All of that kind of thing. The process scheduling is brought to you, and it's that there's process scheduling, right? It is the kernel that tells them, okay, hey, look, the user, you'll be telling the hardware system that, hey, the user gave this instruction first, so you should put this on high priority, right? They gave this instruction takes less time than this one, right? So you computer system, hardware system, you should do this one first because it's not going to take a lot of time, blah 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 blah, all of those kind of things. Yep, it's the kernel that puts those parameters there, and they actually call the kernel parameters, literally, those kind of stuff. And yeah, so they do that, right? And then the other thing is the memory. This task, how much, who figures out how much memory this task is literally going to take? Do we need to get some memory through swap in order to perform this task? Who figures out that, those kind of stuff? Yep, still done on the kernel, right? But most importantly, who tells the kernel which part, I mean, who tells the hardware system which part of the hardware will be used for that particular task, right? The kernel, right? So it's the one that, through what is called, there is a name for this stuff. I always use drivers, but there is a name for this stuff. And I like that name because it brings out the connection between the hardware and the software through they are called kernel modules. Thank you. Okay, I remembered. They are called kernel modules. I'm sure the other name for hard drivers is kernel modules. Well, I'm just remembering vividly. I'll need to check. So, um, if your instruction will need a validation, for example, from the keyboard, right? The kernel knows that, and the kernel sends that to the stuff and expects that the hard um, sends that to the hardware, and the hardware expects that there should be some kind of instructions from the keyboard in order for it to execute that request. Very high level. Remember, I'm speaking about this high level, not literally, right? Because this is not how it happens literally. There are specific architectures in place, but high level, yep, this is what happens, right? And who mounts the file system on the hardware so that the the instruction about what uh, binary should be executed should come from, right? So this is literally all the operations of uh, the operating system right here, and it is being done to you or done for you by the kernel. So it's literally the responsibility of the kernel to take care of the networking, right, on your PC. Quite important there, because if you understand how the kernel is doing this stuff, then you can understand technologies like Docker, then you can understand technologies like Kubernetes, then you can understand technologies like VMwares and generally virtualization, right? Really, really important there. Really, really important topic. So these are the kind of stuff that is being done by the kernel. Have I confused anybody? Anybody lost? No, nobody's lost. So that's wonderful. And yes, there's a kernel architecture, quite not helpful. And yes, there are stuff that we can use to check to work with the kernel. There are commands that we can use to work to see the kernel. And we have this important configuration folder that we can use to add functionalities to the kernel, right? These ones are the generic functionalities. These are the generic functionalities. You can literally write your own program that is specifically meant for your kernel and give and add that as an added function to the responsibilities of the kernel. People are doing it every day, and you can do that because every Linux system provides you this stuff, this folder, and this one, if you are getting it out of your PC, right? If it's something that somebody has done for you, or you want to collaborate with another person, then yep, you can get into your computer using this one, or you can do it yourself and include it here, literally, right? And if you want to remove a module, you can do this one. If you want to see all the kernel modules, you can use this one. And you're wondering what kernel modules are, and they are just codes that extend the functionality of the kernel. They are important when you want to optimize your entire computer system, right? And that's why they are important. And this is literally where our workshop will be based. But then this I wanted us to see. So who did not hear about this before now? Marivon, you heard about these before now? Helpful to know how to structure or present the workshop.
No, sir. Please, I haven't heard about it. So, can you elaborate
Okay,
more?
okay. Favor, same for you.
Yes, sir. Same.
Wonderful. So, yes. So this is the base of where we want to do workshop to understand the kernel. So this session was just to talk about the theoretical part of it, right? There are a lot of stuff that we can do. And if you are interested in things like Rust programming, like I am interested in Rust programming from the image behind me, then this kind of things are important because then you'll be doing some embedded system calls and those kind of stuff and things like that. So, but that's not what we want to do. What we want to do is here, we want to understand how this works, and then hopefully we can also do like kernel parameters and see like uh, how we are getting stuff right. I like this diagram because it's showing you that you give the computer system through an instruction to a computer system through your application. Your application interprets those instructions or translates the instruction to what you call system libraries, right? And then these system libraries are linked, each system library or each system library is linked to a particular kernel module or driver, right? From which the kernel receives the translated instruction, and then the kernel will now schedule whether that is the first instruction that should be uh, executed or processed, the right computer science word, they will be processed. And if it has to take if there's some kind of networking stuff, parameters are included and that kind of stuff. Where should it send the output of the result to which particular file system, that kind of thing. So the hardware will do all of that and send it back to it, and you send it back to it, and then you see it in your application. Literally, that's how it works. And that's why the kernel component is very important. So if you remove the kernel component from here, you have no link to this, and all of your softwares that you have installed in there hardware, they are literally useless. They become void, that kind of stuff. Does this make sense, guys?
Yes, sir.
Wonderful.
But I cannot see your screen clearly.
Oh, I mean, I can see my screen clearly from the call. So, not sure what I should do on my side. I can share something else and share it again. For example, I have this, and then I can share this again, and then ask you whether you see it clearly. Nope, was not for you. So, um, okay, there were misconceptions that was put. And this topic, the system Z and the init, there is system Z, there is sysv, there is init, right? And people usually use them interchangeably. And that's the first thing that I would like to talk about because again, it boils down to how your system works. Not sure this is the correct place to talk about it though. So I'll reserve it, right? I'll reserve this. But how your computer system operates depends on which hardware architecture, honestly, hardware architecture it's being used. And sometimes the confusion is that the specification for creating softwares in 2025 right now, right, is that the software system should be able to run on any hardware system, right? Any software system should be able to run on any hardware system. That's the specification for doing that now. So sometimes it's confusing to know underneath there, like what's going on. But if you're going to be doing this in your job, it's important for you to know. So you know that if you have a system Z system, you're probably using a UEFI hardware architecture. Most probably. If you're using CSV and any of those old stuff, then you're unbiased. Most probably. So the kind of software system, and by system here, software system here, I'm talking about operating system. I'm not talking about your software applications. Again, there's a difference. There's a difference between the software applications and the software systems, right? So by software systems here, I'm talking about like Linux, like Windows, like Mac OS, those kind of stuff. The what they are made of or how they operate is based on this architecture of the hardware that they are based on. And this is probably something for another time because it's huge. So kernel modules themselves, they are not applications, software applications. They are just an integral part of the software system, like I've mentioned again some time ago. And BIOS is legacy. BIOS is legacy means that it's outdated. The BIOS systems are outdated and you should not be using them anymore. Means that there is nobody who is currently maintaining the BIOS system. Literally nobody. So means that there are vulnerabilities there. Attackers can easily use stuff there to infiltrate your system, that kind of stuff. So you should use the UFE stuff. People are still maintaining it. So common misconception, these assignments are not for you. And this is probably the end of this theory part, right? And there's a lab session that I started preparing, but because I had to change it a little bit because I know that you guys are quite new to this, so it's quite good to put like new stuff, right? Not stuff that I'll be alone in the meeting. But if you are not quite new to this, then you can also tell me so that we can dive into it together. Marivon, Favor, any comments?
Yeah, how are we supposed to go with the practical session?
Oh, no, the practical session, we cannot do it now because we are out of time. So I wanted to do this theory session first so that you know exactly what the practical session will be about before we talk about do the practical session.
Okay.
Does that make sense to you?
Yes, sir. Yes, yes.
Wonderful.
Okay.
Hmm. Marivon, is that okay? Is that okay for you too? Okay, Marivon has internet issues. I can see that. That's fine. So, guys, this is the end of this small talk. See you next time, and we'll be using our hands and our mouth to talk because it will be a lap session. So, thank you, and Loni will keep you guys updated as usual. Okay, sorry about today. We can do this better.
Okay, thank you very much, sir.
You're welcome.
Okay, sir. Thank you.
You're
My
welcome.
network is really bad.
Sorry about that. Okay, guys. Yannick, Loni, thank you guys. Talk to you guys later.
Thank you very much, Sinke. Thank you.
Okay.